we need to find I1 and U1. Firstly, we need to connect all components based on circuit diagram. We have resistor, ammeter, voltmeter with internal resistance 10,000 ohm, and DC supply with voltage 10 volt. Firstly, we try 100 ohm as the input, then we run it. Then we get the output here, which is 101 milliampere. Then we try with 150 ohm. Then we run. So here is the output. We get 67.7 milliampere. Then we try with 2000 ohm as the input. Then we get the output here, 51 milliampere. Then we try with 300 ohm. Then we get the output, 34.3 milliampere. And lastly, we try with 1000 ohm. And we run it. Then we get the output here, which is 11 milliampere. For activity 2, we need to find I1 and U1. Firstly, we need to connect all components based on the circuit diagram. We have R1 with value 100 ohm, voltmeter, ammeter with internal resistance 15.5 ohm, and DC supply with voltage 10 volt. Firstly, we try to put 100 ohm, then we run it. So here is the output. We get 100 milliampere at the ammeter. Then we try to put 150. Then we get the output 66.7 milliampere. Then we put 2000 ohm. The output is 50 milliampere. Then we try with 3000 ohm. Then we get 33.3 milliampere. Then lastly, we try to put 1000 ohm. Then we run. Then the output we get is 10 milliampere. So for activity 3, first thing first, we need to connect all the components based on circuit diagram. So we have RL, and then we have ammeter here with internal resistance RA 15.5 ohm, and then we have voltmeter, and the last one we have DC supply with value of 10 volt. So after we connect all, we can find the value of ammeter, which is I1. First, we try value of RL with 100 ohm. So after we run, the value of I1 at ammeter is 100 milliampere. Second, we try value of RL with 150 ohm. So we got the value of I1 is 66.7 milliampere. And the last one, we try value of RL with 300. So we get the value of I1 is 33.3 milliampere. So based on result on the simulation, we got it same with the calculation. So for activity 4, first we connect all the components based on circuit diagram. So first, we have RL, and then we have voltmeter, and then we have ammeter, and the last one we have DC supply, which is 10 volt. And then from the simulation, we can get the value of current and voltage, which is UL and IL. So first, we put the value of RL with 150 ohm. And then after we run, we got the value of UL with 10 volt and IL with 0.06 ampere. And second, we change the value of RL with 300. So after we run, we got the value of UL is still 10 volt and the value of IL is 0.03 ampere. And the last one, we change the value of RL with 1000. So after we run, we got the value of UL is still 10.0 volt and the value of IL is 0.01 ampere. So based on the value that we get, we can conclude that the value of simulation is same with the value of calculation.
Assalamualaikum warahmatullahi wabarakatuh. Today, I will be doing an AC measurement of resistance. I will start with activity 1. So, here is the circuit for activity 1. In this activity, I need to find the current and voltage. So, for calculation value, I use V equal IR and this is what I get. So, for the measurement value, I will be using MATLAB Simulink. And here is our circuit. And this is our ammeter. This is our voltmeter, our resistor, and our AC source. So now let's start with 210 ohm. Let's run. Okay, done. So let's measure our current first. Okay, this is okay, here is the result. We get 47.51 milliampere. Okay. Okay, now let's measure our voltage. Wait. Okay. Okay, here is our voltage wave and we got 10 volt. So now I will be doing 390 ohm, 470 ohm and 860 ohm. Okay, done. Okay, for conclusion, we can see that as the resistance increase, the current will decrease. This is because resistance is inversely proportional to current. Okay, now let's move to activity 2, which is measuring the resistance in series circuit. Okay, now we need to find the voltage in each resistance and sum it to get the V total. And before that, we need to find our current first. And to find our current, we need to find the total resistance, which is R1 plus R2. Okay, now let's find our measurement value. Okay, here is our circuit. Now let's start with 210 and 390. Run. Okay, done. Now let's measure our current first. Okay. Now let's see the peak of the wave. And we get 83.23 milliamperes. Now let's find our V1. Get 17.848. Now let's find V2. And we get 32.46. volt. And now, to measure our V total, we need to sum up our V1 and V2. So, let's calculate here. And I get 49.94. Okay, now I will be doing 390, 470 and the others. Okay, now I already finished the measurement value, and as you can see, if we sum up all the voltage dissipated by the resistor, we will always get the V total, which is equal to our V source. Okay, now let's move to activity 3, which is measuring the resistance in parallel circuit. Okay, in this circuit, we will need to measuring the current across each parallel. So, to measure that, first we need to find the total resistance. And to find our total resistance, we can use the formula of parallel resistance, which is 1 over R total is equal to 1 over R1 plus 1 over R2 and so on. Okay, now let's start measuring the value. Okay, this is our circuit. We will start with 210 and 390. Okay, run. Okay, let's measure our I1. Okay, this is our I1. Let's check the peak here. And we get 47.51. And now our second current. And we get 26.97. And now we measure our voltage. Get 10 volt. And now we need to find our I total, which is I1 plus I2. And after that, I get 74.48 milliamp. Okay, then I will be doing 390, 470 and so on. Okay, now I already finished with the measurement, and as you can see, here is our I total, which is I1 equal I2. We can confirm it by using V equal IR and use the sum of the R load in parallel. And to find our R total in parallel, we can use the formula 1 over R2 is equal to 1 over R1 plus 1 over R2 and so on. And we will get our R total.